Welcome back. Okay, we're solving quadratic equations using our rules of factoring. If you recall from our previous modules, sometimes when you have an expression and you're trying to break it down completely, you may use more than one rule of factoring. Well, that's true with solving quadratic equations. When we're trying to break these quadratics down to be linear equations, we may have to apply more than one rule of factoring. So remember, we're concentrating on the big rules: GCF, difference of perfect squares, trinomial, and or grouping. So it's important, you may be able to do a GCF with a difference of perfect squares. You may do a GCF with the trinomial with the grouping method. So let's go through our example in our PowerPoint and see how this applies. So our equation is negative 3x squared equals negative 12. First thing we notice, it's an equation. It has an equal sign. And we notice it's quadratic because our exponent is a 2. We know step 1 in solving a quadratic is always to set our equation equal to 0. So we like to move our terms to the left side. So we're going to move our negative 12 or our minus 12 by adding 12. On the left side, negative 3x squared and positive 12 are not like terms, so we write them in the correct descending order. So now our equation reads negative 3x squared plus 12 equals 0. It's still quadratic, but now all our terms are on the left side. It's set equal to 0, which means it's ready to factor. But now we got to go through the rules. Remember, when I was teaching you the rules of factoring, I made you memorize them in a specific order. And what is always rule number 1? Very good, it's GCF. If your terms have something in common, whether it be a number or variable, you must divide it out first. So with negative 3x squared plus 12, it is obvious we could divide both of those terms by 3. But now here's the catch. Do we divide by a positive 3 or do we divide by a negative 3? Well, if you remember when we were doing factoring, we talked about when we have an x squared, we always want that coefficient in front to be positive. So we have to decide now between dividing out a positive 3 or a negative 3. We have to think, what number would make that negative 3x squared become a positive? So obviously we're going to divide both terms by a negative 3. So that's going to be our GCF. So we're going to put our GCF in front, our negative 3, and then we're going to put one set of parentheses to see what's left. So negative 3x squared divided by negative 3 would just be good old x squared. And that's what we want. We always want our x squared to be positive. 12 divided by negative 3 would be negative 4. Okay, now here's what's different. We're not done factoring. If you look in the parentheses, x squared minus 4 is another rule of factoring. It's two terms connected by subtraction, and both those terms are perfect squares. So now we're going to do the rule difference of perfect squares. So we leave the GCF negative 3 in front, and now we put two sets of parentheses to factor our difference of perfect squares. And we know our definition. Perfect square means a term times itself. So what times itself is x squared? That's easy. It's x times x. What times itself is 4? That's easy. It's 2 and 2. And because we want a negative 4, the signs would be different. Remember, when we factor a difference of perfect squares, our two binomials are conjugates. Now that we have our equation factored, no longer are there x squareds. We see an x, which means we're linear. And now we're ready to set equal to 0. Now, here's where the boo-boo's going to be. You guys are going to see three expressions multiplied to equal 0. Negative 3, x plus 2, x minus 2. And what you guys are going to do is you're going to say negative 3 equals 0. Ladies and gentlemen, negative 3 equals 0 does not have the variable x. Therefore, there's nothing to solve for. Writing that statement, negative 3 equals 0, is false. It doesn't even make sense. So when you factor out the GCF, you're pulling out that number to make it easier for you to factor the expression completely. Now we don't need that GCF anymore because it's just a number. There's nothing to solve for. So I didn't write anything down. If you think about the concept, every quadratic is going to make two linear equations, and you know you're linear because you have x to the first power, then that's where you write your equations with your x's. So your first equation is going to be x plus 2 equals 0. Your second equation is going to be x minus 2 equals 0. And then you'll solve both by doing the inverse operation. So we'll subtract 2. Our first solution is x equals negative 2. Then we'll add 2. Our second solution is x equals positive 2. Remember, with a quadratic, we always get two solutions. They both will check. If you check them, they'll both work. They'll make the original equation balance. One of the things I want you to also note here is how to write your solution correctly. Depending on the author of your textbook and your instructor, they may have a specific way they want you to write your solution set. One way to write it is just as you see, x equals negative 2, x equals positive 2. Another way to write it would be just to write x equals with the two answers separated with a parenthesis. A third way to write it would be put your solution in grouping symbols that are called braces. You guys call them squigglies. Now, braces are not like parentheses or brackets. They do not mean multiply. Braces just are holding symbols to hold answers. And the last way to write that solution would be to write x equals plus or minus 2. Because 1, 2 is positive, 1, 2 is negative, so we can condense that with the plus or minus symbol. All those ways to write that solution set are correct. Okay, let's go to the whiteboard.